Welcome everybody to Intro to Coding Day 6. Today we're going to cover our last official actual lecture. If you guys look through the curriculum here, you can kind of see it already in my directories. Um, we started on lesson one, and once after today, actually, we see here that lesson seven, eight, and nine are mini projects. Today's our last actual like lecture. To be completely honest with you guys, we probably covered about 90% of everything in the curriculum already. Today we're going to dive in a little bit more into nested data structures, right? We see a small intro of it already with um, nested lists, nested dictionary. We talked about a little bit of it on Wednesday on how we would access it. Today is the specific class for it, so we'll elaborate more on it. I'll answer some questions. We'll talk about how we would access these nested data structures a little bit more efficiently. Um, and why is this important? Well, when you guys get into your programs, when you guys start working with data, a lot of these data structures are going to be very nested. And I'm going to show you a prime example of how this works. We're going to use the Poke API for a demo. Uh, API, I know you guys don't know what it is. Don't worry about it. It's out of scope for you guys right now in this early on stage of your coding time. But this Poke API is actually one of the websites that we use pretty frequently in our courses um, for our assignments and stuff. We love it because everyone knows Pokemon, everyone grew up with it. I mean, Pokemon's still going on too. You know, the games, movies, the shows, everything, right? Very popular. So we like to use stuff like this that everyone can kind of relate to. So the Poke API is really just a website that is hosting the data for quite literally all the Pokemon that have been created. So if you want to make a website about Pokemon, you could use this website for your website. Um, and why we use APIs for information? Well, let's say Jose here wanted to create a browser type of game where you can probably play like the Pokemon trading card game. But he needs to know like the names of the Pokemons, their moves. Ideally, he should have images so we can create Pokemon cards on his application, stuff like that, right? It would be kind of redundant to recreate the wheel. If Jose wanted to start from scratch, he might have to, create a database and manually import these Pokemon and all their information. Why do that if they already exist somewhere in the internet? And that's kind of what this is, right? This is it's called an API, but in layman terms, so we don't get technical and for you guys to understand, really it's just a website that has all this data and they provide it to other users for free, right? So you can use it for your own websites, right? It's meant for developers. You can see here that there's 10 billion API calls each month. That means in combination, there's so many websites out there that are constantly talking to this website here using their data for their own website. So it's a very popular API. And really, I'm just showing you this here because they show you a demo of what their data looks like. Like I said, it's a little out of scope. You're not going to be working with APIs yet, but when you guys get into your programs, you're going to start learning how to talk to APIs and getting information from them. You're going to learn how to create your own version of an API. Um, and we can kind of see here, this is like the URLs to talk to the API. My favorite one is Dragonite, so we're going to use Dragonite as an example. But here is what their data looks like. We're gonna view the raw version of it so you can see exactly how it would look like when you're receiving this on your application. But this is how their data looks like. All right, so whenever my website is using this API and I'm trying to grab all the information for Charizard, This is how I'm going to receive the information on my website. Or my application is a much better term to use. And as you can see, it's a nested data structure. This is a JSON, right? A JavaScript object notation. This is the equivalent of a dictionary in Python. Um, they're pretty much the same thing, just in two different languages. But you can see here that we have like the first key is abilities, which is another list as a value, and this list has dictionaries, right? Or I guess other objects here. And this dictionary has keys with other dictionaries, and it just gets very, very nested in here, right? We have dictionaries with lists, lists with dictionaries, dictionaries with more lists of lists, lists of dictionaries of dictionaries. It gets very confusing very quickly. So you need to be able to feel comfortable on navigating through nested data structures. Um,
Question for you. The up there under abilities, it had the same key twice. Is that allowed in JSON, or is there a reason why it's not
where
airing out? Like underneath abilities, you have ability, that top one, and then right below it, you have ability multi-scale, for example.
This is the start and end of one dictionary, or in this case, one object. And this is the start and end of another one. These are
Oh,
two
okay.
different dictionaries, right?
So it's
These
basically
are
calling different entries, right?
right, right. They don't have names, obviously, because these are inside of a list. So this dictionary here essentially is at index zero, and this dictionary is at index one. So although they share similar keys, they're two different dictionaries, which is okay. Right? If you saw ability twice in here in the same dictionary, then that would be like a reason to ask, like, why is that possible? But these are two distinct ones, right? So don't get that confused, okay? Um, and notice here we have a lot of information here, like ability. You have the name here, and there's even like a URL. I want to show you like the sprites, or I guess the image for it. If we scroll far enough, we should be able to get to. You can see the height, items that the this Pokemon can hold. If you don't know Pokemon, this might sound a little confusing to you guys, but for those of you that do, this should look kind of familiar. ID, location, area encounters. I can probably go to the URL. Let me see what this looks like. Look at that, even more nested data. Location area, dragon spiral tower outside. Let me format this. So there's like a lot of information in here that you can use. Oh, and I should get an ad blocker. Move, fire punch. Right. Let's see if I can find the image for this Dragon Knight. Let's look at this instead. There's a much prettier version. Um, type name. Give me a second. Where is it? Sprites. Here we go. Sprites, back default, front default. All right. Here's the URL for that. Let's see if I can see it. And I can. Awesome. Right. So this API in their database, they have an image of their Pokemon. So if my website, my application that I was creating, I wanted to build like a Pokemon card trading game on my website, or if I wanted to see like a roster of all Pokemon, and maybe build my own like Pokemon team, and let other users do that, I could leverage this other application, this API that already has this data stored in their database, so I can call them. I'm like, hey, let me borrow this URL for your Dragonite image so I can use it on my website. That's pretty much what the APIs are for. Um, and yeah, but to do this, you need to understand how to navigate through nested data structures. And that's what we're going to be talking about today, kind of just practicing. We're not going to do anything like crazy like this, but just slowly talking about how to navigate through the different levels of our nested data structures. Do you have any questions before we start today's lesson? Awesome. All right. So let's go ahead and get started. Data collection review. So this is just the different types of data structures that we've covered, right? Just recapping, like what have you guys learned? We learned about lists, right? This is an iterable that holds different types of data, right? They can hold integers, floats, strings, other lists, or other dictionaries, right? It is an ordered data structure, meaning that you can access it by indexing. It is mutable, right? So you are able to change the different values within a list. And this is just the characteristics of this data structure, right? And stuff that you guys should, you don't have to have it memorize exactly every single thing about it, but have an idea of what a list is up to this point now that we've been working with Python, right? And you see here, we can grab index 0, or we can grab the last item by using negative indexing. The next thing was using multi-dimensional data structure, right? This is your two-dimensional list, which is the first one that you guys saw, which was a list of lists. We covered this very briefly before the end of class on Wednesday, right? And I talked to you guys the process of how you would actually access every individual index within here. So usually when we talk about data structures, specifically nested data structures, um, we like to say the term like the top level or like the root of your data structure. When we use like term root or like top level, we're referring to like the start of where this structure starts at, right? Uh, your top level is going to be whatever is the data structure that's holding all this together, right? And the top level here is the first square brackets, right? The top level here, the root is a list. The root, if this was a dictionary, this would be curly braces, right? So when we say a root or the top level, that's what I'm referring to, right? The first data structure that starts off this multi-dimensional structure. This is your top level, right? So when you were to call my matrix index 1, right, that first index or that first key, if it was a dictionary, that is accessing the top level of that data structure. And as you recall, when I mentioned, when you use stuff like indexes or keys, right, you're returning the value back to that. So essentially, if I were to say my matrix index 1, really what this is returning to me is list 4, 5, 6. And it's important to understand that because when trying to dig deeper into these nested data structures, it's a little bit hard to try to conceptualize how you're diving deeper in there, right? So if I know that this is the equivalent of this, because that's what it's grabbing and returning to me, if I wanted to grab the 6, I would treat this as if I'm calling this specifically first. So if because this is exactly this list, I can go ahead and then append index 2 to grab this. So this no longer returns to me specifically just this list. This will return to me specifically the number of 6, right? So earlier, this was referring to the entire list. And then this is referring to index 2 of the item that's at index 1 of the list of my matrix, right?
And we don't have to have a comma in between those two to designate that.
Negative, no commas. We do not use commas. For example, like I wouldn't say my matrix, comma, index 1. I don't know if that makes sense. But you wouldn't do that here either, right? When you try to get the next one, because you're gonna treat it as if this is a list, because that's what it's returning to you. 1, 2, 3,
So
right?
question, if I did do the comma, would that mean like bring me list 1, which is 4, 5, 6, and list 2, which is 7, 8, 9?
No, you would get an error,
Oh, okay. I tried.
right? Oh, I'm not getting an error. What the heck? Oh, my room might just be on something right now. Hold on. Yo,
It
no,
could also be. It
you
could
were on.
also be the notes thing.
You're on to
Or
nothing, Myra. Uh, it literally just created. It printed out like a list with two in here.
Get out. Eh.
It would not save to any variable. But no, but as you see here, even though I did this, it didn't know who. Like you're like, pretty much like because there's nothing here, it won't know who to access it from. Like, okay, so you didn't specify that you're trying to access a list. All you're telling me is to print out bracket two. So I'm gonna go ahead, I'm gonna print out bracket two bracket, right? That's what it's interpreting it as. It's very deliberate. Have you guys ever seen? It's a very common video. It was very it was out trending for a while, years back. There's this video of this guy, this father. And he has two kids, a boy and a girl, and he tells them that he wants them to write for him the instructions of how to make a peanut butter and jelly sandwich. And he says that he's going to read through the instructions, and whatever the instructions say, he's going to do exactly that, right? Um, so he specifies to them like you have to make sure that your instructions are clear. And he quite literally takes every instruction very seriously, right? And I recommend check him out. It's a very funny video. But this really explains to you um, really what your code is doing. Peanut butter jelly instructions that. And we can watch a minute of this. And this is actually I show this to my foundation programming course a lot because this is it's a great way to understand what your code is doing, right? And why it does what it does. It can be a little frustrating at first because you're like, my code's not working. Like, why isn't it working? My code looks right. I'm trying to do this. Um, but you don't understand why it's not doing it. And we'll watch a minute of this and we'll move on.
Any sense. Jari ruined it on purpose. He knows how to make one.
What's up, the internet? You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter and jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out of the...
That means like a lot.
A bit means a lot?
In my world.
Spread your scoop of peanut butter onto 1 of your pieces of bread with the knife. All right? There we go.
You're doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
Nope.
Done. Closer.
All right. But as you can see, that's quite literally what your interpreter on your computer is doing, right? When you write your code is only going to do exactly what you tell it to do. And that's, exactly what's happening here because we didn't specify what list to grab from on index two. It's just going to say, well, I'm inside of a print statement. You want me to print out the first item of index one of my matrix, followed by, which is the comma, bracket, the number two, and then a closing bracket. Okay, I'm gonna do exactly as you told me to do. So it does so. It prints out the item at index one of my matrix, and then I told it to print out this afterwards, right? And I have that because of the comma. So it does as such. So your code is literally just doing the exact same thing the dad just did. She says, squeeze the jelly on the bread, and he squeezes it on the bread. I'm like, yeah, that's fine. You didn't specify how to squeeze it or where to squeeze it to or where to squeeze it from. So when you guys are writing your code, make sure that you understand that you're calling something. Where are you calling it from? Right? What exactly are you calling, and what you want to do with that? Right? Because it won't give you the intended effect if your code doesn't know exactly what you're referring to. My spouse does this all the time. She likes to talk to me without giving me context, and I stop her. I'm like, I don't know what you're talking about. And then she would like talk for like 2 minutes. I'm like, start again because I don't know what you're talking about. And then she's like really frustrated, like, oh. But if I don't know what you're talking about, how am I supposed to understand? And your Python interpreter is gonna be just like me. Like, I don't know what you're referring to. You tell me print this out, but you're not telling me, from where, who, like, what are we talking about right now? Right? So be very careful when writing your code. So with that said, if I wanted to print out the item of index two, I need to specify that I want to grab my matrix, right? I want to grab the list my matrix, and I want to go inside of here, right? So I want to grab something from in here. Well, which list in here do I want to grab? Well, if I want to grab index two, which is the 6, right, at this list, then I need to grab this list first. So I'm going to specify index 1. Okay, cool. Now that I'm in here, I need to specify where in here I can grab the 6 from. And that's going to be index 2, right? So that's how you want to start off with. Call the list first, call the top level, the next level, and you dive deeper into the data structures within your top level, right? Within your main data structure. In my matrix, a single bracket index will return an entire list, right? Because we have lists at each individual index. To access a single data point, we need to add another bracket with the index of the data point we desire. Again, starting at 0 for forward indexes. All right, and I just showed you exactly how that works. Right, this grabs the list at index 2. So index 0, index 1, index 2. And then we grab the item at index 1. This is index 0, and this is index 1, therefore giving us 8. I see a question. Can you call 2 items from different lists at the same time? You can call multiple items if you use slicing, but if you wanted to call 2 different items from 2 different points, then you would have to be a little bit more specific, right? You wouldn't be able to chain it all at once unless you do something like, for example, print, and I call my matrix again, index 1 at index 0. So I could call them back to back, but for each one, I have to specify where it's at and how to get there, right? So that's the only way I can think of, unless you do string slicing and you give it a start and stop, but you're also going to get everything in between, right? I hope that answers your question, Angel. All right. Also, because lists in Python are mutable, we can change values in place using the assignment operator, adding brackets as we increase dimensions, right? So the same way that we were able to change the value by calling index and then assign it with the equal sign, even though the item is nested, you can still do the same thing too. But you have to first nest your way in there, right? You have to go through the different levels of your data structure until you get to the specific item you're trying to change, right? Here they're trying to change the item that's in index one, which is a list. And inside that list, I want to change the number at index one, which ends up being, this is index one, this is index one. So they changed a 5 to a 500. Right. So there is my matrix right here. You see the 5 here. And then we can print out my matrix again. Oh, I forgot. Let me run this again. There we go. And then there we go. All right, so we see before it gets changed and then after it gets changed. So even though they're nested data structures, it doesn't mean that you can't access them and still change them. You can do that all in one go, but you have to specify which item and where in the nested data structure is it at, right? As we know, lists are iterable, which means that we can loop over them. And how can we loop over two-dimensional lists? We saw this very briefly on Wednesday as well, right? We had to start an outer loop and then an inner loop so we can go inside and grab every individual item, right? We first start with the outer loop, right? The outer loop is going to iterate the top level of your list. We say for row in my matrix, and this is going to return um, a whole list, right? So when this first starts, row is going to grab the very first item in the top level of this data structure. And as we know, it's going to be an entire list in its own. So this will return 1, 2, 3 the first time that we run this. And while we're holding on to 1, 2, 3, we start an inner for loop, right? Every time that we grab something with the outer for loop, we're going to run an inner for loop. So the inner for loop runs for every single item that we grab. So we grab 1, 2, 3, and then we say for item in row. Notice that we're calling row, not matrix, row. And the reason for that is because we want to iterate through here, not the entire matrix itself. Once you grab each individual list on its own, then we can start an inner for loop to iterate through this one. The first thing is you have to grab the first level and then the second level, one at a time. Let's go to TL draw. My nemesis. Somehow I always struggle messing with it. Let's see exactly how inner for loops are working. I'm going to say for let's create a loop actually. Yeah, we'll say 1, 2, 3, 4, 5. Nums is equal to 1, 2, 3, 4, 5. And then I say for I in nums, right? For I in nums. This is I. Why you do this to me? All right. Cool. So we started for loop saying for I in nums. This for loop is going to iterate through nums from start to finish. We didn't specify it starts or stops. So by default, it starts at the beginning and it stops all the way to the end. The step is set to 1 already by default. All right, so the first time that we run this, I is going to equal to 1, right? Now, every time that I run this for I in nums, what I want to do is I also want to start an inner for loop. So I'm going to say for x in nums. And then we're going to recreate this bad boy right here, but it's going to be x. I'll delete this. So we run for I in nums. I immediately starts at the beginning, and it takes up the identity of 1. Right? And I'm also going to say print I, comma, x. So I takes up the identity of 1. Once it grabs that first item, I is equal to 1. Immediately after it takes up the identity of 1, we start an inner for loop that says for x in nums, which now creates another temporary variable, which is our x variable. And x is also going to start at 1. Right? So x here is equal to 1 as well. And we are currently inside of for x in nums. Right? We came in here. And then while we're in here, we start an inner for loop. And we print out output 1, comma 1. It prints out 1, comma 1 because I is at 1 and x is 1. Now, once this line runs, we are done with this code block within the inner for loop. So what happens? Well, we're still within our inner for loop. X started a for loop in here. And as we know, because we didn't specify start and stop, X needs to continue iterating through the rest of nums before we can leave. So after we print out 1, comma 1, this inner for loop is going to reiterate again, and X is going to equal to 2. It'll equal to 2, and it's going to print out 1, comma 2, because I is still equal to 1, and X is now equal to 2. The code block finishes what it's doing, but we still have items that X needs to iterate through, right? Because X is not done. So it goes back around, and X takes up the identity of 3. We go back inside the code block, and we print out 1, comma 3. It finishes. We still have other numbers, so we go back around. X takes up the identity of 4, and we print out 1, comma 4. We have one more number. This inner for loop isn't done. It reiterates again. This time we take up the identity of the last item, and we print out I, comma x, which is 1, comma 5. And now, and only now, that this inner for loop that is complete, now I can move on to the next number. The outer for loop is still running, right? This outer for loop cannot move on to the next item in I until everything inside of this code block finishes running. But within this code block, we started another for loop. So this for loop can't move on to the other stuff until it finishes running, right? Which is why X was able to iterate through every single item and I stay the same because this for loop needs to finish so the outer for loop can go on to this next step. So once we get through all of X's iterations, then and only then does the outer for loop move on to the next item. So now I is equal to 2. So once it takes up the identity as 2, we go back inside of this code block. And Lord and behold, we have another for loop we have to go through again. So it starts all over again for X and nums. Because this for loop starts all over again, X starts at 1. So now we have 2, comma 1. Right? 2, comma 1. And it's going to do that all the way through until this for loop is complete. So we get 2, comma 1, 2, comma 2, 2, comma 3, 2, comma 4, and 2, comma, let's move this, 2, comma 5. Once this inner for loop is done running, this I is going to go to the next iteration, so it becomes 3. It once again restarts this inner for loop, and X, because it restarted, it goes back to 1. And that's quite literally how this happens, right? So, with the context of the nested lists, we have, what was it? Okay. It is a matrix, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I wanted to print out every individual item, I would say for row in matrix, and I would say for num in row, print num. We'll say row. This will start. Row will grab the very first item, which is his list 1, 2, 3. While it has this first item, it's going to say for num in row. So we then start num. Num is going to start at the very beginning of row, right? Once again, it starts at the beginning of row because we said for num in row. Well, what is row? Row currently is at the first list. So num is going to start at the first item of that list. And we print out num. So output is going to be 1. And then this inner for loop is going to go through all of row. So then we go to 2. We print out 2. And then it goes to 3. And we print out 3. And now we have iterated through everything inside of row. So now this is going to go back around, and row is going to move on to his next item, which is going to be the second list. And it's going to restart this inner for loop. But this time, because row is the second list, num is going to be 4. And we go through that process all over again until eventually we get to the last list. We print out 7, 8, 9. Right? Because num is iterating through whatever row is at that moment. Do I have any questions on how nested loops work?
But you should have started drawing on day one. Just saying.
Is there a limit to how many nested loops that you can do before the systems ends up saying, you're dumb, I'm not working?
There is a limit because eventually your computer is gonna like is gonna
It pulls the you're
overflow.
dumb, I'm not working.
Yeah, pretty much, right? It pulls that. But ideally, you want to keep it to 2 nested loops, or like this is as deep as you want to go in nested loops. Once you go into 3 nested loops, like if you have for row in matrix, for num in row, and then for like integer in num, that's pushing it, right? This is okay, still, right? This isn't ideal, but this is okay. It's not bad, right? There's gonna be times where like you have no other choice but to use a nested for loop. Once you have a nested for loop within a nested for loop, it starts getting very subpar, right? The optimization for it isn't the best, and you don't want to get that deep into nested loops. It starts affecting your what we call your time complexity, which is a fancy word for like how fast your code runs. And it starts slowing down, right? Especially if you were to run this nested for loop with a million different items, it becomes it it cubes the amount of operations you have to do. Um, if that makes sense. This,
Yeah.
when using a nested loop, one nested loop, um, it squares the amount of operations to do. For example, right now, if I only had for I in nums, I would print out 1, 2, 3, 4, 5. That is 5 operations. But with a nested loop, for every single number, I printed out every single number again. So this quite literally did this it's doing 5 to the power of 2, so 25 operations. So instead of printing out 5 things, I just printed out 25. Right? If I were to finish this, there would be 25 outputs here. With a nested loop, it goes to cubed, right? The actual specific terminology is O of n cube is the term that of the time complexity. This is O of n squared. Now you don't know what that terminology means, but it's just a mathematical equation that we use as developers to be able to categorize how efficient your code is. But the term cube and square is directly reflecting how many operations it's increasing with the complexity of your code, right? Because this here, it squared the amount of operations you were doing. It went from 5 to 25, right? 5 to the power of 5 is 25, I think. I think it is. 5, 10, 15, 20, yeah, 25. Quick math. We're here, right? It's doing 5 to the power of 5 to the power of 5, right? So this is did it. What's 25 times 5? Or no, what's 25? It's 25 times 25, right? Is that how it works? I don't know, man.
Yeah,
That
it
was
would.
never my strong suit.
So 5 squared would be 5 times 5, and then same on the same on. So
Yeah.
Wow, yeah, okay.
So it
Definitely
just makes it a lot
absorb
more complex.
CPU time.
Mm-hmm. And that's because we have 5 items taught. If you have 100, 1,000, that's too bad, right? That's not good code. As you can see, you don't need to know math to be a good developer, right? Because my math sucks. Tamika's like, yeah, don't ever do math in class again, please. All right,
I apologize.
that's okay. Tom putting me on the spot. All right. The next thing here is gonna be 3-dimensional lists, which is a list within a list within a list. right? Which is what kind of what Todd just brought up. Um, I've seen these before. These are a lot more common, specifically in like data manipulation or like learning, like large language models. You work with large pieces of data like this. Um, so this is not uncommon. This is actually very common. You'll be working a little bit with this when you guys get into the immersive program. Uh, but here it just added another layer of data, right? Here we have one big whole list. The first item in this list is here, right? I can tell by the square brackets, right? The blue square brackets is referring to the outer layer. The next layer within here is the green square brackets. As you see here, here's the first green one, and here's the second one. So here's the first item, and I can also tell because the comma, obviously. Um, but here's my first item within this list, and this list has three other lists, right? And all these other lists have the same. Here is a list of three other lists, and these lists have their own integers as well. So this is a three-dimensional list here. Now here, what they're doing is they're trying to append the word chicken to the row with 19, 20, and 21. 19, 20, and 21. So how do we do this? Well, first, we want to grab, we're going to want to come inside of this list first, right? So we have to call my three-dimensional list, which they do. And once we grab it, we want to grab one of these lists here, right? And because 19, 20, 21 are in that last list here, we can either could have called -1, or what they're doing here is they're calling index 2, right? Because technically this is at index 2. So they call index 2, which returns the last list right here. The next step is we want to grab the list within this list that we're trying to add the word chicken to, right? And as we said, it's supposed to be the list 19, 20, 21. So if I want to grab that first list within this list, I have to call index 0. So you see here that they chain it with index 0, which will in turn return this part of your list. And now that you're within here, now you can append the keyword chicken, and we can print this out. And you see here that we get 19, 20, 21 with the keyword of chicken added to the end of it. All right. So how would you access the value 24 in this case? You just have to keep adding more brackets, right? So 24, it is inside the last list within this list. And inside this list, 24 is at index 1, right? The list at index 1. So we have to grab this list at index 1. And then to grab number 24, we have to grab index 2 within this list. So they do it as such. They call index 2. So here's index 0, index 1, and then index 2, which is going to grab this last big list. They're going to grab the item at index 1. This is 0, and this is 1. Right, that's going to return this list. And once we get access to that one, we call index 2, which is where 24 is at. So they just chain the brackets to specify where to go within here. Make sense? Okay. So this is that outer list, right? 3 dim, right? If I just call 3 dim, that's the entire list as a whole. I want to grab that first inner list in here. So I call index 0, right? Because it's the first. I only have one list in here, obviously, which is this one big list, right? That's going to allow me to get access to this list, and we're going to grab the first item at index 0. So when you start nesting into your data structures, that's quite literally what you're doing with the indexing. You're specifying what level inside of this list you're trying to go to. I want to specify that I want to grab that first item within this level. That first item is this one. And then within here, I need to specify where in here I want to go. I'm going to try to grab, let's say there's a number 4 here. So if I want to grab this third item in here, this is index 0, this is index 1, and this is index 2. So I would have to specify that I want to go into index 2. Right? And I can delete this, delete this. So far, I went to index 0, which was that first item in here. Right? That's what this is doing. Brought me in here. And then I said index 2. So while inside of index 0, I go index 0, index 1, index 2. Now within here, I have to specify where do I want to go? Index 0, index 1, or index 2. Well, I want to get the 4, so I'm going to go to index 1. So it goes into index 1. So when chaining your square brackets, you're essentially just diving deeper into your nested data structure to grab the value that you want. Right? I can't just call index 1 and expect it to know I want this item because it's at index 1. Right? You have to dive deeper into the nested data structure and specify every level that you go through, every level, every room, every floor, right? That's essentially what we're doing here. We're just going deeper into this hole or this bunker or this house, whatever you want to call it, whatever helps you visualize it. And you see here that we get 24. We're gonna take a break here because time is 7:03. We'll take our first 10-minute break of the night, and then we'll come back. Our actual official lecture will probably just run up until 8 because this is a very short lesson. After we're done with the lesson, we'll do exercises. And if you want to go after the lecture's done, you can also go. So we'll take our first 10 minutes of the break of the night, and then we'll be able to finish out the second part of this lecture in a bit. I'll see you guys in 10 minutes at 7:13. All right, welcome back, everybody. We're going to continue from where we left off. I know a lot of stuff might have been stuff that we kind of already covered. That's okay. It's really just trying to understand how this works. I know even though you guys don't ask questions most of the time, there's always somebody that's confused. So how do we loop through a nested data structure within another nested data structure? Really, when you think about something like this with 3 layers, it's like a Rubik's Cube, which is what the image is trying to convey, right? There are 3 layers, each containing rows and columns. So you would use something like this, where it's a nested loop within a nested loop. You don't want to get this far in. It's not an issue if you're working with small amounts of data, right? Now, if you were like working with a large piece of data and you having to iterate to so many pieces, so much piece of information, it can get very complex. But when you have stuff like this, there's no other way. You kind of have to kind of go in there. Another reason why I love dictionaries because they're so much more powerful, and they get away from all this additional complexity when trying to access nested data structures. So the outer loop is going to iterate over the layers one by one, right? So it grabs like big chunks, right? These lists with lists. For each iteration of the outer loop, the middle loop iterates every other row of that layer. So we do for layer in my 3dim list, and then we do for row and layer, and then for item and row. So we are just really dissecting this piece by piece. First, we grab the list of lists. And then while we got each individual list, we'll go through one list inside of here at a time. And every time we go through one of these lists, we go through each item in that list, right? So we need 3 different loops to be able to grab the 3 different levels of the information that we're trying to grab in here. And that's what this nested for loop within a nested for loop is doing, right? And this allows us to grab every individual item, one item at a time. So if any questions on how the nested loop works, really it's just adding another loop to it. Nothing really changes. You're just having to do more operations. Adding and removing elements works the exact same, right? So these are methods that are with lists. Nothing changes here, right? How do we add 20 in the middle of, or sorry, how do we add 200 in the middle row? Well, first, we have to grab that row and then we have to add it in there, right? So we will say my matrix, and I will grab index 1, and then I would say dot append 200. And then I can print out my matrix. Right? So just like the code implies, we first grab that first list, 4, 5, 6, right? And then once we have it, we append the 200 to it, which will return to us the new list with the appended 200 integer. You can append an entire other list itself as well. And you see here 400, 500, 600 get added to the end of it. So just because they're nested does not mean that you cannot use the built-in list method. Same thing
And
with
the append is just adding to it, right? It's not replacing a number that's in that list. It's just increasing the amount of items on the list.
Yes, by default, append will add it to the end of your list. Yes, you're adding it, not replacing. Replacing rows and columns, right? To replace a row, simply assign a new list to that row index. So nothing changes. Here they're grabbing index -1. What's -1 in here? Well, it's that new list we just added at the end, 400, 500, and 600. And they're quite literally just reassigning the value at this index here with a whole other list, 10, 11, and 12. And it replaces it. Here we have for I range, they're calling the length of the matrix. Does the new list need to have the same number of items? No, it is not restricted, right? I don't even have to add a list here, right? I could say my matrix dot append the character of 8. And I added, so let me remove this. I'm gonna run this again. Oh, it didn't add it? Okay. My matrix dot append. I press enter by accident. Right, here's the 8. Right, just because they're nested. What do we say about lists? What do they take? What type of data?
Strings, right?
Just strings?
Iterables?
Iterables.
Iterables.
Iterables. That's what we call it. What we call a data structure that you can iterate through. But what type of values do lists take?
Strings, integers, Boolean values,
Yeah, everything,
everything.
right? Everything. Does a new list have to be the same number of items? No, right? So, Angel, you just said multiple values, right? So you just answer your own question. We take all values. And we've seen that before already. We take strings, integers, floats, other lists, other dictionaries. It does not matter. It does not matter the size, whether small or big. It does not change how lists work, right? We can take all values. That's the cool thing about Python. Do they have to be the same? Do they have to be different? They can be the same. They can be different, right? That's just the characteristics of lists, right? If I told you dictionaries, what do they take? They take key value pairs. What does the key have to be though? Right? The key has a different way of working. What does a key in a dictionary have to be?
Has to be a string.
No. Good try.
Unique.
Unique. It has to be unique. Um, it has to be unique. Um, Typically it's better to give it a string, like a string name, or maybe even you can even give it a number. But unique is really the biggest in there. Like it has to be unique. What about values? What should the value be? Angel, what do you think the value should be for key value pairs and dictionaries? What does it take?
It could be, I'm trying to think. I've worked with them before because I did a project for
Mhm.
class in the, but that was like one of my first classes that I did. And I had to build a spaceship map and I had to use key value pairs to access the different sections of the ship. And
That's cool.
yeah, and like the key would be the main deck, and then the value would be the item found on that room.
Oh, that's
So
cool. Yeah.
like I have, for example, the sick bay would have the medication pad or something like that. I don't remember exactly what it was, but that's what I had for like the entire map of the ship. So like the name of the section and then the item inside that section.
Yeah. Well, in short, the values of a dictionary could be anything, just like lists. They could be strings, integers, other lists, other dictionaries, right? Even if you have nested values within there, a value can have a dictionary that could have other lists of other dictionaries. We saw that with the API, JSON data, right? So just because you have nested data structure doesn't change the, you know, how this stuff works. It doesn't limit how big stuff has to be. If you work in Java, Angel, I think that's might be why you're getting confused or why you would have that question. Other languages they do have restrictions like that, right? Because theirs isn't a list. They're more natural native data type. It's called an array, and those are typically restricted, right? So they when you create an array and you set it to 5 items long, then it can only take 5 items, right? If you create an array of strings, it can only take strings. In Python, that's the beauty of Python. Doesn't matter. It could be long, it could be small, it could be of any data type. We don't discriminate over here in Python. We're cool like that.
I
Oh,
wasn't I'm sorry. I wasn't too detailed when I typed my question. I was referring more to, you see how you have matrix index -1, and then you're
uh-huh.
reassigning the value 10, 11, 12. And before that it was like 500, 600, 700, I think it was.
Right.
So when you reassign a new value to it, does the list that you're passing in or the new assignation that you're giving to it, does it have to have the same number of items as the previous one that you're
Okay.
replacing
No, it does
with?
not.
No, okay.
Yeah, I can see why you would ask that question, and that makes sense. But no, it does not matter. It could be a whole different data type. It could be a string. It could be a float if I wanted to reassign there. All right, it does not matter. But good question. All right. The next item here, the next piece of code. Who can tell me what this is doing? Someone walk through me the steps of this code and describe what is happening here. I knew Jose was gonna volunteer. I saw him sit up. He's like,
I
my
was
time to
waiting,
shine.
but I don't want to. I don't want to
No, no,
try.
go ahead.
I'll probably
Give
get it.
it.
I'll probably get it wrong for
That's
sure.
it's fine. That's fine. Then we can learn together.
So for item in the range, and the range that we're declaring is going to be the length of the list of my matrix, which we see
Right.
above is it's the range is 0, 1, 2, 3, 4, 5 with A being now appended to it. So it's got 0 through 5. So the length is going to be 5 right now. So for an item in that length, and from 0 to 5. So for the index, the item and enumerate my matrix. So for index, item, and enumerate matrix, and then the index. So basically is um now within that index, all right, because we're going a nested loop. So within that one I of within that index and the item within that index. So for instance, the first one, 1, 2, 3, we'll use that and enumerate my matrix I. So I being the placeholder, or no, actually I is not a placeholder. It looks like it's the actual first thing, the index, and enumerate. So if the index is equal to 1, then the ma- then the then the I index item is times 100. So basically, you're going to take every single item within the list and times it by 100. So for instance, if you go, he's going to take index if index equals 1. So that's the one that kind of confuses me right there. So I kind of understand like it's going to take box, it's going to take like the first index 1, 2, 3, and it's going to take the first index of 1, 2, 3, or it'll take number 1 of index 1. So, but the one that confuses me, I know I'm confusing everybody now, where it says if index equals 1, then the matrix will then take the item of that index, and then it'll take that item times it by 100. So by definition, if the index is equal to 1, so meaning if it's 0 and then 1, and it's in the ones place, then it'll take that item and it'll multiply it times 100, and it'll do it for the one that confuses me. So like let's say for instance in this instance, 1 represents 4, 5, 6, 200. And then so would it take just would it take only 5 of 4, 5, 6, 200 and just multiply that 5? But it doesn't the only thing is it'll keep looping. So then my question is, does it stop right there? Because it doesn't say anything after that.
You were kind of close. But it's okay. I generally didn't expect you to understand it. But I know it can be very confusing. Let me just reset my matrix and give me issues. Um, where was I?
Yeah,
matrix.
and the other one, to be honest, I don't memorize what enumerate, um, what that does,
Sure.
and
Okay.
but I
So
have an
I'll
idea.
talk you guys through it. So for I in range, let me go ahead and just make sure that my matrix is good. Okay, good. Here's my matrix. It has four different lists, right? 1, 2, 3, 4, 5, 6, and I should probably get rid of this. Um, 7, 8, 9, 10, 11, 12. So we say for I in range of the length of my matrix, how long is my matrix? 1, 2, 3, 4. It is 4 items long. So
Yep.
this is quite literally just saying for I in range of 4, right? Because it's gonna grab the length of my matrix. You're close. I think you're getting confused with like when you specify range, like the start and the end, but we didn't specify a start and the end. We just
Oh,
specified
it's just it's just four. There's four logs there, so it
right.
doesn't matter if it's
4
zero.
items in here. We're not talking about indexes. We're talking about the quantity of items within of my matrix. It is 4 items long. So
Okay.
for I in range of 4. So this is going to iterate through 4 items, right? That's how long it is for I in range of 4. We're not, let me rephrase that. We're not iterating through 4 items. We're iterating 4 times, right? It might be a little confusing at first, or it's actually look uh it's like deceiving you. You're thinking like, oh, I'm iterating through my matrix, but you're not. You're using the my matrix to get a number that's relevant to you. Because you don't know how many items my matrix could have. It can have 10, it can have a million. All I
Yeah.
need to know is I need to iterate for however many items are inside of my matrix. So how do I figure out how many items my matrix has so I know how long my for loop should iterate through? Well, we can use the length method to figure out how many items there is in here. If it's only 4 items, I only need to iterate 4 times. If it's a
Oh,
million, I need to iterate
that's
a
where I
million
was.
times.
Okay. Yeah. So earlier I was saying when I was asking, like, I don't know if it's just gonna keep looping or if there's something that ceases it. This is what's gonna cease the loop or stop the
Yeah,
loop.
it's only going to do this 4 times because that's as many items that my matrix had. But
Okay.
so this will iterate 4 times. And then every time that we iterate, we're doing this. Well, what are we doing? We say for index, comma, item, and enumerate. And enumerate, we mentioned this during the for loop class, I think. I think it was Wednesday. Enumerate allows you to iterate through a list, but not only while grabbing the element, but it's also going to return to you the index of where it's at. So it'll return to you index and the element. But because we are getting 2 values in return, we need to know how to handle that. So we pass in 2 values here at the start of the for loop. So we say for index, comma, item. Because enumerate, I think it says it here, returns a enumerate object. The enumerate object yields pairs containing a count from start, which defaults to 0, and a value yielded by the iterable argument. So it returns 2 items, the index of the item that we're on and the item itself. So, well, from where? What is it enumerating? It's going to enumerate my matrix at index I. At index I. So when this first starts, I is going to equal to 1 because the outer for loop started a for I in range of 4. So when this first starts, it starts at 1. So this is saying my matrix, oh, I'm sorry, correction, it starts at 0. It starts at 0, but it's going to go from 0, 1, 2, 3. So 4 items, but it starts at 0. So
So is that kind of like saying like automatic without request when we put I, it's basically automatic unless we specify a place of I, it's automatic without request so that it starts at 0 at index 0.
no, that's how the range method's working. This
Oh,
is the
okay.
range method. It starts by default at 0, right? Range starts at 0 unless you specify where, and it goes up to, but not including the stop point. So that means when I run length of my matrix, that returns the number 4 to me. So this is going to iterate for I in range of 4. Range is going to start at 0 and it's going to go up to the number I passed in, which is 4, but not including. So it's going to be 0, 1, 2, 3. It's 4 items, sure, but it's starting at index 0. So with that in mind, the first time this inner for loop runs, I is going to equal to 0. So it's going to grab the index 0 at my matrix, which is going to be the first list. Right? With that list, we have the index where it's at, which is obviously it's at index 0. And we have the list for grabbing, which is this list. Oh, correction. I misspoke. We are grabbing this list, but we're iterating through it. So an item is going to be 1. And index will be 0, but inside of this list. So 0, 1, 1, 2, 2, 3 for index and items. And now we're checking, hey, if the item we're currently on, if the index is equal to 1, I want to grab that item and multiply it by 100. So this is going to grab every single item in each one of these lists. And then if the item that we're on is at index 1, we're going to multiply it by 100.
Dang. Okay. Yeah. I see now.
And that's what you see here. We see 200, 500, 800, 1100. Because they grab that item, 2, 5, 8, and 11, and then multiplies it by 100.
Sweet.
But that was a good attempt at reading code. Good stuff. All right. Here for I in range of 1001. For what range of numbers am I going to have? Where's it starting and where's it stopping? Jose.
So this one's going to start at, well, if the range is 1001, if I compare it, it doesn't say length. So that's where I kind of confused where it says like length of,
You don't need length.
Oh, so this one would just be the length is automatic given. So would it still be 0 all the way out to, or would that just be the length? Just 1001 is the length straight where it's straight.
Don't let the length method confuse you. The length method has nothing to do with range.
Okay.
Okay. The length method has nothing to do with range. Why did we use the length method? Who can explain to me why? Anybody else besides Jose? Danny. Oh, Danny raised his hand. Sorry, Todd.
No, you're good.
So we use the length method to tell Python, hey, we're gonna use the length of my matrix, so it's based on that my matrix number instead of so for range 1001, it's we're telling Python from 0 all the way to 1001.
Right. The range method, it just takes a number percent, just one number. It doesn't matter how you pass in this number. I could do something like this. I could pass in the string of 1001, but I need this to be a number for it to work. So I would have to do int, and then I would wrap it around the 1001. Right? Yeah. Whatever you're doing here doesn't matter. At the end of it, it has to be a number, though.
Okay.
Right? So range only takes numbers. And I want to iterate through a certain amount of times to be able to grab every item inside of matrix. Well, instead of guessing how many items are in here, there could be 5, there could be 10. I don't want to take a guess here and just pass in a random number and hope I grab every individual item. Jose, you have to go? Okay. You're good. You have a good night, Jose.
Yeah, they're calling me down right now.
It's okay. It's okay.
I'll catch up and work on these exercises this weekend because this is where I'm actually my weakness is looped when I was doing the exercises the other day. So I'll definitely be on Slack this weekend.
Sure thing. I'll be around. You have a good
Yeah.
night.
You too.
But as I was mentioning, right? So we want to know how many items we want to go through. And the item that we're trying to iterate through is matrix. So if I want to know how many items I need to go through for the matrix, I might as well grab its length and then use its length as a way to know how far my range method has to iterate through. Right? That's the reason why we use length in there. But here we're saying for I in range, and as I just mentioned, the range by default starts at 0. And then when you pass in the range that you want to iterate through, it's going to go up to, but not including. So this should iterate from 0 through 1,000. Although we pass in 1,001, the range method starts at 0 and it's going to go up to, but not including. So this should return 0 through 1,000. And we're saying if I modulus 100 is equal to 0, I want to print out I. What is modulus doing?
If I is evenly divisible by 100.
Right. Exactly. Modulus is technically division, but it works a little bit different than regular division. Instead of giving you the actual division, it's going to give you a remainder, which is why it's known as the remainder operator, right? It's another name that other people call it. But it's going to take I, it's going to divide it by 100. It's going to return to you how much is left over after it divides it. So quite literally, it's trying to give you a divisible of 100 and give you the remainder. So if it returns 0 to me, if this returns 0, then it'll pass this check where it's saying I modulus 100 is equal to 0. It's checking if this will return to you an even number. And if so, I want to print out I. An even divisible of 100. Let me just rephrase that. So when we run this, as I mentioned, I start at 0. So 0 divided by 0 will return to you 0. So this will pass. So it prints out 0. And it's going to keep doing this. And the next time it gets to a number that's divisible by 100, it's 100. So it does I modulus 100. So 100 modulus 100, right? It'll divide it evenly because 100 fits into 100 one time with nothing left over. So it'll return to you 0. It'll compare it against a 0. So it prints out I, which was 100, the number that we were at. So it'll return to every 100 number. Other nested data structures. So we talked about lists. How about dictionaries? Right? Here we have the English-French dictionary. This dictionary here has a key of hello with a value of bonjour, right? The string for a key and a string for a value. This isn't new. We've already seen this. I kind of already talked about it briefly, right? Here's the hello key, which has the value of a list. Bonjour and salute, right? If I want to access a specific point in this list, first and foremost, I have to grab this value. This doesn't change. How do we grab values in dictionaries? You have to call the key that corresponds to that value. So first and foremost, we call the dictionary and the key we were trying to grab, which will return to me the value of bonjour and salute. And because it returns to me a list, I have to treat it as a list. So afterwards, I have to specify the index. And I want to grab bonjour, so I give it the index of 0. And it gives me bonjour. All right, we already covered this one. All right. So here we have our first actual nested data structure of try. The answer is below. But the school has a data structure that contains all personnel associated with school, teachers, parents, and students. Having access to only the parent info, the parent's key and values, how would you find out their children's names? Yeah, it is this one. Okay. So it has the answer for you guys already. Unfortunately, this would have been a pretty cool assignment. I should erase the answer. But how would I find out the children's names? Who wants to give it a try? Just visually looking at it. Someone that hasn't looked at the answer. Once again, the school has a data structure that contains all personnel associated with the school. Notice that this is a dictionary of key value pairs where the values are other dictionaries. The first key value pair here, the key, it seems to be almost like some kind of ID. I see person 1, 2, 3, 4, 5.
Well, that's the parent's name.
Right. There's some kind of the values assigned to each one of these IDs. Sure, go ahead. Who was the last person that just spoke?
I was going to say, so that first line is going to have to be your student ID. And then you'd have to look at it for, if you're trying to pull up just the student information, you're going to have to do a if else with is student equal to true, because it has one of those values in there of is student or is teacher. And then you'd have to have it looking up the actual first name of that student, or pulling back the value for first student line.
My guess would be to do something with the key of whether the parent has any children value. If children has any kind of index equals true, maybe.
So wouldn't it be like you're looking, because we see the one where it says children and they have that first person has 3. That next person has none. So we don't know who person is on any of these, but we could say person is that first section, or identifies the list by person, and then we do a sub list, right? So you would say, look for, go deeper in the list like we did before, and find the one that says children, and then call out who is in the list. Would that be right?
Close. I think the answer is here, but I don't want to check the answer right off the bat. But looking at this, obviously the name is very abstract, or the ID is abstract. And this is not a student ID. Don't get that twisted. This is personnel ID, right? And I know that because inside of the values here, I see 2 keys. One, it says is student or is teacher. So this could be a student or a teacher. Who knows, right? So if I wanted to figure out, how could you find out their children names of the parents? The names of the children that belong to parents. Well, first, I want to know who is a parent and who is a student. So I might want to iterate through here, and there's going to be a bunch of if-else statements. We want to make sure that the if student is set to false, right? Because chances are, as you see here, if student is true, no children. If student is true, no children. If student is false, this isn't a student, and it's not a teacher either, but they also don't have children. Guardian is also set to false. So this might just be like, administration staff or something. They're not a guardian. So I just noticed that we have guardian is equal to true. So guardian could be a parent, it could be a grandparent. The point is they're a guardian. Guardian here is true. Also, its student is false and its teacher is false. Guardian is false, but they're students. Guardian is false, but they're students. Guardian is false, but they're not a student nor a teacher. So this might be like maybe a janitor. This might be the counselor, something like that, right? Guardian is false. They're not a teacher or a student, so another person that's just staff. Guardian is true. They are not students and they're not teachers, but they also have children. right? So every time I see that guardian is true, I see that they have children. Next one, guardian is false. They don't have children. It says if they're students. Guardian is false. They're not a student, but they're a teacher, and they don't have children. So from what I can tell from just reading through this data, parents have guardian is true. Because only the people that have guardian is true have children. And they also have its student being false, and also its teacher is equal to false. So I could probably come to a conclusion that if guardian is equal to true, most likely they're not a student, they're not a teacher, and they also have children. So the parent is probably going to be guardian is equal to true. So once I figure out who the teacher, who the people is, I can see that they have children. So once I figure out if they are a parent, I'm going to grab, I'll probably create some kind of other dictionary that collects all parent data. So I'll have an initial loop that's going to come through here, and it's going to check the ID. If the ID of this person that I'm going through, right? If I find one of their keys to be guardian and that's equal to true, then I'm going to save this ID into a dictionary, like a parent dictionary with their ID. And I'm also going to grab the children key and grab the value to save it to that person. So I'll have a formatted dictionary with all parents and a list of their children in there. Once I have that dictionary of who is the parent and who their children are, then I need to figure out the name of the children by iterating through that new formatted dictionary. Because as it stands right now, it's a little cryptic, right? The children list is a list of personnel IDs, but there's no names. So I still have to go through and figure out what the names of these people are, right? So it's a multi-step process, but really it's about navigating through this data structure, figure out who the parents are, having some kind of formatted data structure to hold the information of the parents with their list of children. And once I know who the parents are and who their children are, I can go through again this dictionary and find out the names of the children. So let's look at the answer. Here we have a list, or sorry, correction, an empty dictionary called names. It's set by itself. They then iterate to the school dictionary and grab keys and values. They check if the key of children is greater than 0, right? So let's say, for example, they have this one here. They're going to check if the length of that person at the key of children is greater than 0. This person is not greater than 0, so they'll probably skip this one. But if it's greater than 0, for example, like this one, they'll probably get to this one. They'll check the children. They'll see that it's greater than 0. There's a child in here. Then they're going to format parent name is equal to. They format a string where they grab that person and their first name and their last name to form a formatted string of that parent name. They then add that parent name as a key to this dictionary called names and set their value to an empty list. Within here, they start a nested for loop to iterate through their children list to grab the IDs, and they once again come in here, this time looking specifically for the parents and appending it to that new formatted dictionary. And what the heck? Oh, I need to find this. Let me run this. I know it's a little complex, right? A lot of stuff going on. But at the end of it, they're able to have a formatted dictionary called names, where the key is that formatted string they created, and the list is the name of their children. So there's two parents here called Jim Smith and George Gonzalez. One has 3 children and one has 1. Notice that they both have the child called Kelly Smith. So I guess they're both co-parents or parents to that one person, where one of them have Jimmy Smith and Robert Smith. So maybe like a step parent. I don't know. But Jim Smith has 2 additional children, but they share one child together. Do you have any questions of what this code is doing?
Yeah, can you explain what KV is doing in this code?
KV is the key value, right? How do we get the keys and the values in a dictionary? We use the dot items key, or sorry, not key, the dot items method, right? This is a built-in method for dictionaries that returns to you the keys and the values within it. That is what KV is, right? Where specifically do you want to see where K and V are being implemented that you're confused in?
No, I get it now. I was just confused if it was just like naming like a variable like I or
Yeah,
something. But I understand now. So the K is for the key in dictionary and the V is for the value in that dictionary. So
correct.
it's just I get it. Thank you.
Awesome. Any other questions? When it loops through here, it's grabbing one of these. The key is the school ID, and the value is the data for that student ID. Right? So when they do value index children, they're quite literally grabbing the value of this person and they're grabbing the children key to return a list. So that's how they're able to check that list and see if it's greater than 0. When they create a formatted name, they're calling the dictionary. They're checking the key of the person they're currently iterating through, which will bring them here. And they're grabbing first name. So they'll grab the person they're currently iterating through. And then again, they'll do that again, but this time they'll grab a last name. Right?
So, with that names and then the bracket parent name, and then it's giving it an empty list. So names at the very top is a dictionary, right?
Correct.
So how is it using names there?
It is calling the dictionary names and assigning a new key value pair, where the key is going to be the parent name that they defined right above.
Oh, okay.
And then they're assigning it an empty list.
Right, so that they could put the children.
Yeah, so they can put the children in later.
Okay.
So they're pre-formatting it. They're adding a new key value pair in there where the key is that string and the value is an empty list.
Got it. Cool.
Another question? Anybody? Awesome. We've seen this already. And I believe this is, yes, this is for you guys. All right, that is going to conclude today's lecture. As I mentioned to you, we are at 8 o'clock, so we are at that 2-hour mark, like I guessed earlier. This is one of the much earlier classes. So we are going to stop here with the official lecture. And the last hour will consist of the exercises. We can cover anything that we have covered in the past 2 weeks, or we can talk about today's lecture if you guys have any questions. That's what this hour will be for. But for those of you who do not want to work on this now, you guys are good to go. This is the official lecture. It is done. We're going to go straight into the weekend. Next week on Monday, we will be covering Mini Project 1. This is the easier version of all three of these projects, where we are going to come together and we're going to use everything that we have learned so far to solve these problems. Um, Really, we're just wrapping up the course and learning how to utilize the tools that we have covered up to this point, right? The biggest issue that I see for new programmers and the biggest comment I get without fail is, Roger, like, I've sat through the lectures, I've gone through the exercises, I've seen the recordings, uh, but I feel like I understand the information, but right when I get behind a problem, I forget everything, or I don't know how to apply the tools. Right? I know how to work with lists, I know how to work with dictionaries, but the moment I read the problem, I don't know where to start. I don't even know where to begin. That is the by far the biggest comment I get with these exercises. So the mini projects are going to help us kind of try to understand how we bring it all together and how we start these problems. So the way it's going to work on Monday, Wednesday, and Thursday is we will come in. I'll talk briefly about the mini project or the exercise really and what it's asking of you. And then we will break into some evenly divided groups, 2 to 3 people probably. And I will open up breakout rooms. I will give you guys an honest, genuine try. You guys will try it out for about an hour. And then you will come back. If you guys finished, then you will explain your code. If you didn't finish, then I will do a talk through, walk through, step by step of how to reach a solution. And then, I'll explain to you guys my thought process, how it went. Um, Throughout the time that you guys are in breakout rooms, I will be jumping back and forth and then, helping out where I see people struggling. But that's how it would go, right? This is going to be Monday, which is manipulating strings. This is a much easier one from all of them. Mini project 2, which will be Wednesday, is going to be recreating the Powerball lottery using Python code. Um, so we'll show or we'll work on how to recreate the Powerball lottery, how it works. Pretty much creating like the winning numbers, creating your own lottery ticket, and then running a simulation to see if you won or if you didn't. And depending how many matches you get will depend how big of a prize you get. So we'll use code to recreate the Powerball lottery. And then on Thursday, which will be the last class, our mini project will be poker. So you will write Python code to create uh, a deck of cards, and then you will essentially create a hand, right? So your user, your player, will get a randomly generated hand, and then you will rank the hand towards what you get. Depending what your hand is, will determine um what ranking of hand you got. And then we'll have like a player two, and then we'll compare hands to see who has the highest hand and who won. Right? We won't recreate the entire poker game, but we'll recreate some of the logic using Python code. And all this will start off with groups where we will then come back into the main lobby and discuss the code, or I'll either walk you through the entire process, or you guys can discuss yours and we could talk about areas uh, of friction of that you might have struggled with, right? I don't have answer keys to any of these, so I will be doing it from knowledge and then a little bit from memory from without I taught this before. But for the most part, I have nothing written down, so I'll just be doing it on camera in front of you guys. And then we can talk about possible solutions. All right. That'll be next week, right? That's where we wrap it all up and whatnot. But besides that, that concludes this class. If you have nothing else for me, you guys are free to go. I will see you Monday. For the rest of you who are going to be working on exercises, I will be here where I will help you guys out on any questions you guys may have. But besides that, thank you all for showing up today. I hope you guys have a great week, and I will see you Monday.